everybody. Welcome to Quinta do Bonfim for this masterclass about climate change related included in our SumCamp 23. My name is Fernando Alves. I'm in charge for R&D activities in Symington Family Estates group. Along with me is my colleague Joana Valente. It's part also of our R&D team for viticulture. So we have more or less 2 hours for this masterclass, and we start with some very brief information about the region. So we are speaking about one region and at least 2 great wines for Port and Douro. And only to show you some information very simple about the Douro region. So the total surface of Douro area is about 250,000 hectares. The vineyards use more or less 20% of this surface, around 45,000 hectares. Normally, we divide our region, the region is divided in 3 sub-regions, the Baixo Corgo, the Cima Corgo on the middle, and Douro Superior in the eastern part of Douro. And you can see the shape of the vineyards located in the region, more dense in Baixo Corgo, also a very high expression in Cima Corgo, and less vineyards in the Douro Superior area. So we are speaking about a very steep slope region. We can compare in this graph all the European mountain and steep slope wine regions. That means not only Europe, but we can compare these around the world, because the world normally speaks in mountain viticulture. It's a matter of elevation, not steep. And for example, easily we can see Douro compared with all other steep slope wine regions as more than 50% of total surface in difficult areas to grow vines and grapes in this kind of land. Another point very important for our region, we have a diversity of vineyard systems. Since the beginning, the stone terrace, later for mechanization and to rationalization of the activities in our landscapes, we have large terraces of 2 rows, that big evolution for the vertical rows, up to maximum 30% now of the slope in the hill. And nowadays we use only narrow terrace for 1 row, and with different geometry and sizes in the terraces. So, related to soil, or what we can say about soil, you can see in the left picture is normally leptosoils. That means the the surface of the soil is very thin, normally around 40 centimeters of soil. Then we have the bedrock, is schist, that easily broken to have a preparation of soil. In the past, this work is done by hand. Nowadays, with heavy machines that can work the soil to prepare at least at 1.5 meters deep in order to put the root system in this kind of soil. So the final result, so soil characteristics, we can say that are facing as soil, but normally is as very stony soils with a low pH, low organic matter content in soil, medium in phosphorus, and normally medium to high in potassium. So we also work for the sustainable development of steep slope vineyards. This is a map, is a 3D map of this property that we use. Is a cooperation with a different project, but we use this kind of information to make the plan for our new vines, and in order to get the best geometry in the terrace construction in order to reduce the problems related to erosion and the optimization of soil surface. For example, we are going to visit this in the afternoon. This is a soil preparation, for example, for vertical vineyards and also for terrace vineyards here on the right side of the picture. As you can see, with the help of new laser technologies, the parcel's geometry needs to be like the construction of a house, with high precision for the roads, for the slope of the terrace, and all these elements are crucial to reduce the problems related to erosion. And this is crucial even, for example, for mitigation of the climate change aspect. For example, the extreme events that happens related to thunderstorms in our region, is important to have a precise construction of our landscapes. Otherwise, you are at risk to lose a good quantity of soil to the river. Related to climate, our annual precipitation is higher in the part of Baixo, normally around 800 millimeters. In the middle part, we have an average of 600 millimeters, and in the Douro Superior, we can get between 400 to 500 millimeters of rain during the annual precipitation. If you look for the growing season, these values can vary between near 190 to 300 millimeters. And for example, during the ripening stages, we have a very few quantity of water from rain to our vines. For the growing season temperatures, we can see in this map that was building in the project managed by Hadvid with the help of the Professor Greg Jones in the past, and this was published in 2012. For this, we can also see how the temperature for growing season develops around the region. More hot or very hot near the river, and we can see along the higher elevation of the region that are a reduction in temperature. So that means this special variability of the temperatures in the region can give us some opportunities to adapt our vines for the warming. Related to the warming, this graph shows the evolution since 67 up to now. The temperature, the average temperature in this area in Pinhão, in Bonfim. So as you can see, there are a trend of a positive evolution of the temperature, but the most important contribution is the minimal temperature. As you can see, the slope and also the correlation, but the slope are higher for the minimal temperature. That means this average increase of the temperature is more or less to the lack of cold days than the warmer days, but still exist both for this contribution. And what we can say about from this study for future projections for the Douro region over 3 different emission scenarios, we can have a range of growing season warming from this size, from 0.8 to 1.8 Celsius from, for example, for the time of 2020, 2050, and 2080, and the reduction of the annual precipitation from up to maximum of 7% or 22% in the 80 in the worst scenario. But for example, if you look for the projections for 2020, was yesterday, most of the average values we can get, and these projections was made in 2010, so that means, so we expect to have more or less the same kind of trend for the coming years. So also a brief information, this is a special information from the 3 scenarios, the B2 scenario, A1B, and A2. So that means B2, the less aggressive scenario, the A1B, the worst scenario, and the A2, the average scenario. And we can get the difference and how is projected the evolution of the temperature in the Douro region for these three emission scenarios was the scenarios available when this study was done. Nowadays, we use the RCP scenarios, and very soon the new scenarios, the SSP scenarios, will be applied for new scenarios. So this is a constant evolution from these projections. And for example, a very recently study done in Portugal for all the wine regions in Portugal about the extreme risk from weather, extreme risks for Portuguese viticulture, and shows with this index, the Euclidean distance, so that means this is a score of the principal components for drought and extreme temperature all together, that gives the risk for the different wine regions. As you can see, for the period 71 to 100, so the red dots are the most dangerous regions in risk related to these information. Another curious information is a very recent paper published a couple of months ago, is information about how we can find the relocation of the bioclimatic suitability of a bunch of grapevine varieties. For this presentation, I only selected Toriga Franca from Douro and Anton Vaz, a white variety from Alentejo. And in these three maps for Iberia, along with France and Italy, we can see in the left panel the historical data, and in the other two panels is the future bioclimatic suitability for these grape varieties for two scenarios, intermediate scenario and the worst scenario for the RCP climatic scenarios. And you can see that this suitability for these vines, for these varieties, moves a little bit for other locations, but is only related to the macro scenarios and macro indexes, bioclimatic index. Sometimes related for changes in elevation and other kind of adaptation that we need to develop other more precise tools to look with higher precision at a region level or a plot or a sub-region level, how this can be changed in coming years. I only to ask your attention for this beautiful project that was leading in recent years by the University of Villarreal, UTAD, along with other partners, that works for adaptations and made a beautiful green paper for adaptation strategies and climate change threats, and also for the long-term adaptation strategies. I invite you to assist the video that was available in the web page of this project, that in this video it's easy, is very well done, the summarizing of all these issues, activities, and initiatives for the future at different levels.
Europe is the world leader in wine production, with a strong impact on its economy. The biggest challenge being faced is to reverse the negative effects that climate change and extreme weather events have on wine production. During the last decade, the increase in temperature has led to shifts in the grapevine's growing cycle, influencing berry ripening, wine composition, and typicity. This impact makes it necessary to develop very specific adaptation strategies and thus reduce the impact of climate change in order to maintain the European wine sector competitive. In the short term, that is for 1 or 2 seasons, there are several strategies that help ensure a sustainable future. Appropriate canopy management helps delay the vine's development cycle and prevent the final stages of maturation from occurring during periods of high heat. To illustrate, a well-performed leaf removal can reduce water consumption, and also postpone ripening until a cooler period. Applying sunscreen creates particulate films on the leaves, encouraging the plant's metabolic growth and reducing sunburn during periods of high heat and water stress. The use of protective nets also reduces sun exposure. Supplemental irrigation. Given the growing scarcity of water resources, irrigation must be implemented with water savings in mind, while still complying with the production rules of wine regions in order to maximize its benefits. Drip systems optimize the amount of water allocated to each vine, while plant water status indicators can be used to optimize irrigation scheduling. Soil management. The use of specific plant species used as cover crops in vineyard interrow spaces contributes positively to soil fertility, depending on whether we are in a dry or wet season. Some plants compete very little for water and promote soil fertility and health. This all helps maintain the vine's vigor and prevent soil erosion. Pest and disease control. The control of pests and diseases should be constant, since climate change may exacerbate them. Long-term adaptation strategies comprise of all the measures that require structural changes of vineyard system. Training systems. Long-term strategies start with changes in training systems that should encourage heat and drought tolerance, reducing the accumulation of sugar content in grapes, and lessen the impact of temperature and radiation in the cluster zone. Cyan rootstock combinations. Another important measure to adapt to climate change is the selection of suitable cyan rootstock clone combinations to preserve wine's typicity while delaying grape ripening to better deal with the increase in summer temperatures and dryness. Although challenging, the goal is to find new varieties and clones that are more resistant to dry and very warm climates. Vineyard relocation. In more extreme cases, the relocation of vines to higher elevations, coastal zones, or areas with low sun exposure may be required in order to take advantage of more favorable climate conditions. Climate change is here, and educating the consumer to gradually adapt to different styles of wine resulting from modified terroirs is also very important.
Okay, so after this video, what is our capacity to adapt in our region? First of all, using our topography. So with our elevation and exhibition of our landscapes, we have a powerful tool to adapt for different scenarios for our grape varieties. Then, along with studies of zoning for grape varieties, with a combination of GIS tools, that means Geographic Information Systems, that works a bunch of different years collected from the last 15 years in our properties for more or less 1.4 thousand parcels spread in our properties. We can use all this information to study the behavior of each variety related to each location. That means study about terroir effects. And then with the classification of our properties, parcels and vines, with the support of aerial infrared image that classify with different vegetation index, how is the behavior and how the vigor of different plots or different properties are related to the quality, yield, and strategies for the management of these vines is very important for us. And with the combination of these two tools, I can give you an example. For example, you recently visit Vesuvio here on the right side of this picture. As you can see easily from Vesuvio, that facing you in the other side of the river, you have another property, Senhora da Ribeira. If you look for the two properties and we draw a transect in this area, like made a slice in the topography of this area, and we're building the profile of both landscapes. We can see the river, Quinta de Senhora da Ribeira on the left side, Quinta do Vesúvio on the right side, and this means the profile of the different vineyards to the both properties. And for example, we have two weather stations, one in the side of Vesúvio, another one facing at same elevation in the other side in Senhora da Ribeira, and we can compare the temperature of these two embankments, of these two banks, the right bank and left bank, with different exhibitions to the sun. And sorry, because we lose the signal here, was a short technical problem. Yes. Yes.
Sorting out the technical issue. So obviously moving, I'll speak up. So moving the size higher up is not only very expensive, but
yes.
There's also the question, like, do you work together with IVDP as well? Because obviously the elevation in terms of qualification for the Quinta, for the beneficio, is very much weighted. So if you move higher up, you can lose grades. Unless they actually
get So it's a rational question, but it's a very difficult to answer very quickly for you, because we made some contributions. Because first, the classification of the vineyards or the punctuation method was on the time brilliant. It was brilliant. The people and the person in charge for this made a great job, and without the tools that we have nowadays. But we need to, nowadays, it's more easy to classify with higher precision some of these geographical features like elevation, exhibition, and others. So, but now we have some new information about this, but it's more something that the region and the regulatory bodies needs to promote in order to apply these new tools for a new vision about these criteria for classification. Yes, yes, for sure. So we come back. So using these two weather stations is very easy. It's located there in the profile of the hills, as you can see here, and looking at made an examination of the climate data for different years in these locations, what we can find in average. For example, the south exhibition property is higher in temperature for near 0.9 degrees Celsius on average, and for example, easily you can find a reduction in temperature with the elevation. So, with a combination of these topographic features, we can have a very wonderful tool to adapt for different evolution of the scenarios related to the climate change. Another one, maybe one of the most powerful, along with our topography features, is our grapevine biodiversity. Why? Because Portugal in the national catalogue has more 343 varieties, and the most important thing is near 250 are indigenous varieties, and from that 115 was cultivated and authorized in Douro region. So it's a lot of genetic biodiversity that we can use to adapt. Not only variety, but also the clones of this variety. And for this, there are a very important body, is the Porvid. Porvid is the Portuguese Association for Grapevine Diversity, which Symington is one of the founders members with high contributions since the very beginning. For example, we have in some of our properties, namely in Quinta do Ateide and Quinta Cavadinha, more than 500 clones in different experimental fields that use a surface near 6.5 hectares. And this is a huge work developed for a large team in the past for more than 40 years for both things, a conservation work with this contribution with more than 100 researchers in partial time that made a preservation of thousands of genotypes to more than 200 varieties. This is a kind of work, is more or less that building the Noah's Ark for the preservation of the diversity of these varieties. It's not a collection, it's a strategy to collect a complex and a very large number of different genotypes from same variety and put all together in the preservation field in order, if you need to recover a different variety or recover a variety from the past, you can at least using the diversity of this population to start a new work for this variety. So this is a wonderful job promoting by this association, and also very important is the selection of clones related for the gains and relation to the environment. For these, for example, more than 70 varieties, there are a lot of selection field trials, and since '84 they start the polyclonal selections. And nowadays is the first country to certify a polyclonal selection. And what this means is not to select one clone for one variety, but at least a bunch of clones, for example, 7, 10, 12, 15, that are the mix or the blend of clones that can give you more resilience of this variety to works in different climates and different environments. And this was studied with a very precise methods of quantic genetic and precise methods of math that can show how is the gain for the variety if you use this bunch, this blend of different clones. And this is a wonderful tool to adapt for the near future. So now it's time to pass the word to my colleague Joana that speak about the strategies to adapt and techniques that are in use inside Symington for this adaptation and mitigation.
Okay, thank you, Fernando, for this wonderful introduction. So, as we saw previous in that video, climate change requires mitigation and adaptation strategies, and we should select different kind of strategies, short-term or long-term. Short-term, those that we adopt during the growing cycle, and other ones that requires more time and planification, those like vineyard relocation or variety change that should be prepared before the vineyard installation. Normally, irrigation is present as a short-term strategy, but we believe that is not exclusively a short-term strategy, because irrigation requires planning, structures to irrigate, and everything that involves previous planification when we are installing the vineyard, and also because when we apply water, we are influencing the vines and their behavior, and the water has this cumulative effect through the years. So we put the irrigation in between the two strategies. Today I will speak a little bit. Fernando already gave some lights about our work at Symington, but I will speak a little bit about what we are doing to adapt to face the climate that we already know that has changed. So, from this topics, what we are doing nowadays in our company, a little bit of everything. Applying or at least studying, trying, experimenting a little bit of everything. As Fernando told, we have this advantage of being in the viticulture, mountain viticulture area, so we can play with elevations and exhibitions. So we have this advantage, and we also consider that in our case, vineyards layout is also a very important thing to face the adversity, because we can select a kind of vineyard or the orientation of the rows for a better position to the vines. And I will start to speak a little bit about this project that is very, very important that we have in Symington, the Symington Grape Libraries. They were established in 2014 with the aim of contribute to the preservation of some of the local varieties that used to be planted and very common in the Douro, but that are not anymore. And also to promote the vine diversity here in our region. In these grape libraries, we don't have exclusively Douro varieties. We also study other varieties from other wine regions in Portugal, and we have also some international reference to compare their behavior in the same climate with our indigenous varieties. These camps are very important to study viticultural parameters and to know their enological potential. And we use these fields also to cooperate with several R&D departments and universities, not only in Portugal, but also in other countries, mainly European countries. Our grape libraries, nowadays we have 3. They are located 2 in Cima Corgo and 1 in Douro Superior. I will start speaking about the grape library from Ataíde in Douro Superior. Ataíde is a flat area where we have our organic vineyard. Let's wait for the train. It was installed in 2014. Here we have 53 varieties, red and white. In this field we have 200 plants per variety, so it is a good number for each grape variety. And here we have represented the most important varieties in the Douro, and some of the most important varieties from the other wine Portuguese regions. And as I said previous, we have also some international reference, red and white, for comparison. In the same year, we installed the second field with siblings plants, okay, the same vines, here in Bonfim. Here in Bonfim, we have a plot with a different configuration. We have narrow terraces and vertical rows with the same exhibition, which is a very good opportunity to study their behavior in different kinds of vineyards. Here we only have 29 varieties. We have also some whites, but in less number, are only 11. And we have less plants. We have the range varies between 25 and 75 plants per variety. And the last but not the least, tapadinha, which is very, very important. Probably you already heard about tapadinha, because you probably have tasted already Pequeno Dilema. Yes, okay. Tapadinha is our property with this grape library collection with 11 white varieties. Tapadinha is in Valença do Douro, and the vineyard has an elevation of 580 meters, so it's high. Yeah. In these grape libraries, we study Lots of things. First of all, phenology. It's very important to understand the life cycle, the growing cycle of these varieties. If their cycle is short, is long, if they have later bud break, if their variation is early or not, everything, all these things are very important to understand their behavior related to climate. And we do this work since 2017. In Bonfim and Ataíde, since 2021 in Tapadinha, and we follow the same protocol as VitAdapt project in Bordeaux. This protocol requires visits to these plots 3 times a week during bud break, flowering, and vibration, and we evaluate the development to determine when is the day of the year that these varieties reach 50% of these phenological stages. And then, after variation, during the ripening period, we collect samples every week to evaluate the ripening dynamic. Our lab analyzes more than 20 parameters, so we have lots of information about these grapes and how they develop. And we are focusing our study mainly in sugar accumulation dynamic. And we are also starting to study some part of other primary metabolites. But today I will show you some preliminary results just to have a look of what we can obtain with this work. In this graph we can see only the mid-date for variation. This is the average value for the 29 varieties we have in Bonfim and Ataíde in common. Okay? Not the 53, not all the varieties from Ataíde, but 29 we have in common in both grape libraries. And we can see that from the first, Toriga Franca is the first one to reach 50% of variation here in Bonfim. And from the first to the last, which is Toriga Fêmea, we have 19 days of 19 days of interval, which means that we have a huge space of time between these two grapes. And the orange dots are related to the same varieties, but in Ataíde. And we see that Toriga Franca is also in the top 3 there. And the last one is also Toriga Fêmea. And they have an interval of 18 days between the 50% of variation. And also very, very, very funny was to understand that even variation, we already knew that bud break and flowering was always first here in Bonfim. But we never had noticed that variation is also first here in Bonfim, because we always think that Ataíde is hotter, the climate is different, so probably variation is already first there. And the fact is not. It's here first, and then the maturation period is shorter there in Ataíde. And we can see that in Bonfim and in Ataíde we have more or less the same varieties. The first group, you cannot see the green square around the first dots, but we can see that the first group of varieties reaching 50% and the last ones are more or less the same in both places, which was very interesting to see their behavior in completely different variety, completely different climate conditions, but they maintain their behavior. Here I will not be very exhaustive. My sound is off, but okay. We have the mid-date variation for all the 53 varieties of Ataíde only, exclusively at Eid, and we have 19 days of interval between the 50% of each variety. And in the right side, we have a work we done with maturation, the ripening values analysis we do weekly, and we did a work of interpolation for a specific target value of sugar. We decided to do this interpolation to values between 180 grams per liter and 220, and here we have the values for the day of the year when these varieties reach this target sugar level of 200 grams per liter. And we see that we have a range in this, only in these 53 varieties, we have a difference of more than a month, 35 days of difference. It's a lot, yeah. But we cannot forget a very important player in this game, the rootstock. Many times we always speak in grape varieties, when we forgot what is under the soil, which is the rootstock. We do this work in this field in Quinta da Cavadinha. This vineyard was planted in 1997, so it's an adult vineyard, very important for us. In this vineyard, we have this trial with 4 different varieties combined with 5 rootstocks. And we do since the beginning of the century. We are studying different parameters in this vineyard in cooperation with the University of Trás-os-Montes e Alto Douro, and with ADVID, which is an important association here in our region. We are mainly focused in the relation between the rootstock and the variety, and how the rootstock can influence the expression of the varieties. And just to give you an example, we can see in this graph the effect of the rootstock for 2 varieties, Touriga Nacional on the top and Touriga Franca. And what we see in these different colors is the number of days that we have first from the January 1st until bud break, then from bud break to flowering, from flowering to veraison, then from veraison to the target sugar level of 200 grams per liter, and for 220. And what we see is that the same rootstock has a different relation according to the grape variety. We see that, for instance, the rootstock seems to do not have a high impact on phenology and sugar in the case of Touriga Nacional. We see that 110R Richter seems to anticipate the veraison. But in case of Touriga Franca, we don't see effects on phenology, but on sugar accumulation. And Touriga Franca is a very important grape variety for us. And we see that there is one specific rootstock that seems to promote higher sugar accumulation. So have this kind of information is very important when we have to plant. We must plant a new vineyard. And we need to decide which rootstock and which variety we will put in this place for the next 30 years. Regarding soil management, as Fernando explained you already, our soil in the Douro is very special, very unique, and very poor, with lots of stones and low organic matter and low pH, everything. In our vineyards, we try to keep natural cover crops, and in some cases, we sown cover crops to improve the soil structure, to improve the biodiversity, trying to get better soil structure and to increase the availability of nutrients for our plants. Regarding extreme events protection, in our vineyards, mainly in those that are facing south, where we have more exposure to sunlight, and we normally have some problems of sunburn and everything. We do applications of kaolin and biostimulants to turn our varieties more resilient and more resistant to these, to the higher temperatures and the high exposure to sunlight. And now we will stop here. We will do a 10 minutes break. Yes? Okay, we have something to eat or drink. And we will be back in 10 minutes.
Hello, we are back for this talk. So we need to speak a little bit about one of the issues very important for us is the water management in a drought area with this kind of warming. The management of the water for the vines is crucial for our production. So this is the general concept about soil-plant atmosphere relations, because we need to take care about the soil water potential and how atmosphere moves this water through the plant to the atmosphere. So we need to evaluate not only the leaf area, different concepts of the use of this capture of the energy and the energy balance in the canopy, because is the balance between all these elements that promote that CO2 goes inside the vines to promote photosynthesis and all the metabolism of the vine, but also the vine lose water through the transpiration. And is the balance between these 2 points that gives the best results for our vines. Some informations about this, for example, for the dynamic in soil plant atmosphere, we use a lot of information and we look very deeply to the soil. We have, for example, an experimental model set up since 2020 that combining water potentials in the vines with soil moisture measurements to study these relations. And we use, as you can see, these access points for probes that can measure up to 1 meter deep the different layers of soil at each 10 centimeters of the soil, and this gives us a very beautiful information, for example, that we can summarize in this graph because we examine soil previous from this project that started in 2020, but we start to study this behavior in soil. For example, we use only this example for 4 layers of the soil, 30 centimeters, 50, 70, and 90 centimeters, the red line in these graphs, since 2017, and for each viticultural year that starts in 1st November and in 31 of October, we have these weekly measurements that give us a precise information about the dynamic of the water for different layers in these seasons. And easily you can look for 2022 was a very drought year compared with all the others. And for example, starting with this information for our viticultural team and also enological team, for example, it's easy for us with this kind of data early in season, in February or March, say, so guys, we need to be prepared, we need to start to use all other mitigation measures to adapt for a very challenging year. But we need to have this information because it was impossible to recover at this point the moisture available, the water available in the soil. And some other information related to the soil, sorry, I'm not seeing what happens
Wait.
in the screen. No, I lose my signal. If you can assist me, I'm losing the connection to the big screen. But for example, what I want to show you with these next 2 slides is some brief information related to the concept about the importance of the water for vine. And starting from this very simple information, we take this information and we take this behavior to apply different tools for monitoring the water in our vines. But firstly, and very important for a grower, we need to understand what means water and how the water works in the vine. For example, here we have a draw for a vine, and normally the water only flow from the soil to the atmosphere through the stomach of the leaves, first from soil to the root to the trunk, stems, leaves, and then go with the transpiration action to the atmosphere. And the adjustment in subflow xylem between the availability of the water in soil and the level of transpiration gives the information about the water potential or the plant water energetic status inside the vine. So that means the value that we can get when we take a measurement from these vines give us the information about the internal deficits, if they exist or not exist, in order to have this information to manage our vines. And, and for example, this is a kind of quiz. Can you see some difference, not the compact C, between these leaves in this picture, for example, or for sure you can see some burns in some leaves there, but for example, if you compare the main leaves in this picture, it's impossible to say there are differences between these leaves in this canopy. But if you look deeply with a thermal camera, for example, very easy, you can see that this picture here, this leaf here, has a different color. That means a different temperature from the other leaves surrounding this one. And what we saw, for example, we take this data from a cooperation of a colleague from the University of Porto, and this central leaf has 10 degrees Celsius higher than the others. So this is a kind of tool. Our colleagues apply a liquid paraffin in this leaf, so that means stop the transpiration of this leaf, waiting for 20 minutes, and took another image with a thermal camera. What they represent is when we stop the transpiration, the temperature rises for, in this case, for 10 degrees. This is what happens to the vines when there are no water in soil. That means the leaves acts as a tool to cooler all the vines. If they cooler the vines, that means they made good transpiration, not so much, must be in balance, and then they promote higher photosynthesis, higher quality compounds, and even promote some stability on the yield. And based on this, so starting from the natural factors, climate, soil, and variety, grapevine variety, this is the factors that give us the vine water status. And no water stress, we need to understand what is excessive no water stress, for example, increasing a berry size and vigor, and this gives some negative effects on quality and for sure improve the yield. But also, for example, if we get a water stress excessive, for sure we get some physiological disorders with negative impacts inside the vine, with reduction in quality and also reduction in the yield. So we need to work in balance between these two extremes to get the moderate water stress for our vines. And we need to understand what they mean, a moderate or controlled water stress that control the berry size and vigor, and that improve the quality of the compounds and other metabolites for this, and which is and for sure we get positive effects for quality, and we can keep the yield for these vines. And for example, if for the first point, for no water stress, we can apply drainage systems, some cover crops, or something that reduce the vigor and control the vigor, but for the excessive water stress, we need to, or moderate water stress, we need to apply a depth irrigation. That means apply, or how to apply, supplemental water that needs for the metabolism of the vines. And for this, we need to apply, for example, this is only pictures of different tools that we currently use in our experimental vineyards in order to get data to give to all the vineyards in our management some information about how to do this management of the water. For example, we apply some very new systems of subflow system. That means that measure online transpiration of the vines, and this is in correlation with the soil availability and the demand from the atmosphere. We also do some micrometer variation of the trunks that also can be related to the water consumption, water inside the vines. But the most important tool for us since a long, long time was the solent chamber, or a pressure chamber that measure directly in the vines, in the canopy, the water status in the vine. And we can apply this method in pre-dawn, just before the sun comes to the vineyard, but also we can use this to access the evolution of the water potential of the vine related to transpiration during the day. Is the pictures on the right side to make a demonstration how this works, a technical part of this works. And the final results for this is our decisions to apply water are based in the vine water status. So this is an example, for example, for Touriga Franca and Touriga Nacional, without irrigation in one of our experimental trials, and we can compare how is the behavior of these vines in 2020 compared to 2022. This is very important because at certain time, at certain value of this potential of the water inside the vine, we need to take decisions, or to apply water, or to do another different management in the canopy in order to have the correct water status for these vines in order to develop the best quality for our needs. Now, another tools that we apply also to manage and to support decisions. Now we are going to speak a little bit about how to take decisions and speak a little bit about the tools that we apply from recent, past and ongoing projects that promoted new DSS, that means decision support systems, that are open not only for the viticultural team, but at the end of the projects also open to the region and the world. Joana?
Thank you. In fact, I will speak a little bit about a few projects we have been involved in the past years, recent years. As you can imagine, this kind of information that Fernando showed us about water potentials, about soil moisture, all these things are time-consuming, are hard to obtain this kind of information, and so we are always looking for ways to turn it easily. And so there are things that we are not able to do alone. Our research and development team is not able to do it alone, and so we are always looking for partnerships and international consortiums to have the cooperation with teams that are able to develop things that we don't have the expertise or the means to develop. And so the first one I will present you is the Vine Scout. It's a vineyard. It's a robot to use in the vineyard. In the two pictures, you can see the first and the last prototype. This project already finished. The robot is it's ready to be in the market. They just need a company that be interested in sell it and turn it commercial. But this equipment is completely autonomous, so we don't need to put a map. He can orientate himself with the GPS and some sonar devices, and so he can circulate through in the vineyard without any kind of human interaction. And we can, and he's built in a plug-and-play concept, so you can put any kind of sensor that you want to take information in the vineyard. During the project, we tested with two kind of devices, and we are mainly getting data about NDVI, so vigor and building vigor maps, and another information that could inform us about the water condition of the vines. I will show you the last video from the project. So, taking data is very important. Collecting data is very important, but we also need to take decisions with this information, and it's and it's necessary to know what to do with this information we collect in the vineyard. More or less during the same period of time, we've been involved in this project, another H2020 Research and Innovation Action, VISCA, Vineyard Integrated Smart Climate Application. This project aimed to develop this decision support system. If we think about the climate change and all the uncertainty we will have in the future, it's very important, everything that we could have in advance, anything that we can know with some days before, it's very important to take action. And in this decision support system, we had climate forecasts in different time scales. We had phenology models for prediction when the phenology stages will occur, and we also had a part that gave advice about the vineyard management, namely with two specific interventions, canopy management and irrigation. Regarding canopy management, here in Symington, because in this project, in this consortium, there were two end users, two wine companies trying this tool and testing two different canopy management, actually three. I was not remember about Codorniu, but yes, three wine companies testing these two canopy management operations, and us here in Portugal and Spain, we tested crop forcing, which is second pruning after flowering to delay the maturation period. And in south of Italy, Mastro Berardino tested severe trimmings, different kind of trimmings to evaluate also the impact in the growing cycle of the vines. Nowadays, we are part of this consortium in VitiGeoS project. It's also a platform, but a little bit different from Visca. In this case, we have lots of different services in this platform, and using the Earth observation services that are open source in Europe. We combine the satellite imagery with sensors in field to get information. We have also here all the climate forecast. We have disease models and warnings and advisory about the interventions. We have phenology forecast and detection done in different ways by satellite and with in-field cameras. And this project aims to give to the wine growers all the information and in advanced early warnings for we can take action before the problems. I will show you the video as well.
On the other hand, more than 20% of greenhouse gas emissions worldwide come from agricultural activities. This demonstrates why today sustainable agriculture is more important than ever. The European-funded project VitiGeoS contributes to the increasing sustainability in the wine industry by offering a platform for optimizing day-to-day field management. Based on the integration of earth observations, combining satellite data and sensors in the field, VitiGeoS platform offers services providing advanced weather and sub-seasonal and seasonal climate forecasts, crop status indicators, phenological monitoring, disease warnings, crop water demand requirements, and the tool for managing business operations and sustainability assessment. VitiGeoS aims to deliver a reliable decision support system to winemakers for smart vineyard management, supporting sustainable grapevine cultivation at an economic, environmental and local level. The platform, being co-developed and tested in vineyards of 3 European wine producers, boosts vineyard sustainability and eases the industry adaptation to climate change. VitiGeoS, striving for more sustainable vineyards and winemaking.
So, just to finish this part, being involved in these international consortiums allow us to try new things, improve our own trials and experiments. And now I will give the floor to Fernando to finish this section. And
so it's a very short information, only to give you some news about the projects ongoing nowadays. We start very early. It's an update from previous project. Now we selected some of our new projects based on the resilience and recovery program from Portugal in the consortium Vine and Wine managed in the ID research tasks by the UTAD from Villarreal, and we are involved in 6 projects in this main framework of this process, but only select 3 related to the climate change and climate adaptation. Namely, the very first one, the Vine Adapt to Climate, under the management of the Professor João Santos from UTAD, with this consortium inside this project. And the main tasks of this project is to access to climate projections with high spatial resolution, higher than we get at this moment, a work to evaluate the risk of extreme climatic events, and study also the impacts of climate change in different aspects of the production. And an important thing inside this project is creating a living lab. We are managing this part also for intelligent climate strategy service, or better, how to apply all these things that Joana explained about mitigation tools, how to apply these in precising these experimental fields that we call living labs. So it's more or less not only it works in projection scenarios, macro scenarios, but looking at the level of the vine to apply these tools at this level. Another one is the MISCI for wine, is also a consortium inside of this project. And the important things and important goals of this project is the study of the new exogenous particle film formulations. That means sunscreen protection for the leaves, and a different new formulations to study in field. And also there are a second part of this project is to study different strategies for cover crops that promotes the microbiome and soil quality. For example, we start the last autumn the establishment of new 7 strategies of cover crops, different plants in soil, in order to examine the impact of this new mix in soil. And another one is the BioGrape Sustain. This one is led by the Institute of Agronomy from Lisbon, along with these teams in the consortium. And the most important tasks for this project is to study and identify, made a molecular identification of new genotypes, for example, discover new varieties, the application of tools of bioinformatics of the gene transcription in order to understand which are the genes responsible for different tasks that these vines, these varieties apply to deal with heat and water stress, for example. And then, which is the gain in abiotic and biotic stress tolerance related, for example, to the clonal and clones selection and study of this behavior for these varieties. And lastly, the study of the microbiome diversity of vineyard ecosystems and how this can help to the health and to promote quality from the soils, from the vines, and from the wine in these products. Only to finish, and as a commitment for the near future, and as part of our ambitious climate change strategy, Symington is recently, or 2 years ago, certified as a B Corp company, the very first one in Portugal for wine. We take part of the International Wineries for Climate Action that works along also the first one in Portugal to go inside this association. And we are very recently, was 2 weeks ago, the very first company that get the National Sustainable Wine Growing Certified for sustainability according the rules that IVV promote for Portugal. So this is our overview about our talks for climate change and adaptation, and more important also mitigation aspects for our vineyards. And now we are free and available for a short
yes, we have
slot of
5 minutes to questions if you have some doubts.
So, okay, I need to give my microphone.
I just have a question on irrigation and the soil management, because I've spoken to Claudia Bourguignon. I met them last week, very famous soil experts. And I understand that the climate here in the Douro is very hot and the soils are very poor, but do you think that irrigation is something that you always need in the future as well? Or if you promote a better soil kind of activity and balance, that you might not need irrigation in the future?
Okay, so we know very well the conditions in Burgundy. I can tell you that recently we have a very short cooperation with Professor Benjamin Bois. He's one of professors of Dijon University that are related for climate, soils, and these kind of actions, because we share some of our samples from Chardonnay in our grape library from Ataïde to a study about metabolomic of Chardonnay and Pinot Noir around the world. And they deserve these ones that grows in a very warm conditions. And Benjamin Bois visits us 2 times at least for this one. So when we speak about deficit irrigation or applying some water, so we need to take care for all the mitigation strategies that we can apply. So first, we need to choose the best location for the vines. Then we need to promote the health of the soil. Then we need to have a balanced canopy management in order to reduce the water needs for the vine. Then what I say in one of our slides is how to apply supplemental water. So only if we need, we apply some water to the vines. For example, I give you a practical example for this year. Based on our measurements in vine, in order to define if we need to apply and which is the amount to apply. For example, we start our measurements in 15 May. For sure, in Portugal, we have a different climate this year because we have a heavy rain during the last autumn. During the winter, for example, December get 4 times more water from rain than the average. And even in the first 10 days of January, we have the average rain of this month in 10 days. So we are totally plenty of water at this time. But since January, almost until May, there are a lack of rain like in all European countries. And when we start to measure in May, the values that we get give us the information that we need to apply some water in falling day. But in falling day it starts to rain. And during 1 month, we get near 90 to 100 millimeters of rain. So at this moment, based on this information, based in the canopy management, based in, for example, we start already to apply some sunscreens in our leaves. So we delayed the needs to apply this complementary water, maybe only, this is a kind of breaking news, so I need to look for the camera, maybe on the next week. Maybe on next week. So that means We are behind the normal time to start this, but it's only possible if you get this correct information from the field. And I totally agree with your question, because it's not the holy grail to solve all the problem, but we need to look for all the framework to act in the water management. Water management, that means all the techniques that you can promote to reduce the water needs, the water consumption, the water transpiration, and so on, to the vines.
Yes, it's not only irrigation, it's all the agricultural practices you can combine to improve the vine water consumption and help vine to manage correctly the water available.
Another question? Yeah. Yeah.
So I saw that a long-term solution is relocation of vineyards. But in terms of, to what extent do you think that using or different clonal selections of vines is able to sustain the vines where they are right now and give the right type of fruit or quality of fruit?
Yeah, this is an interesting question, but for sure, we don't have time to show all the data that we can not only collect, but the data that we can get access with, for example, in cooperation with Porvid, the association. For example, related to clones. Touriga Franca is a very important variety for us. For sure, you learn a little bit more about Touriga Nacional, but Touriga Franca represents near 25% of total grapes planted in Douro. And for example, in one of our properties in Quinta do Teide was established the very first field trial for the study of clones for Touriga Franca with 120 clones installed there, with each one with 4 replications. This field was planted in 84, and in the very first years was studied by all this team that nowadays belong to Porvid, this association, study the behavior of these clones for yield, for quality, and so on. Since last years, we have, through the works of Porvid and the development of Porvid, we get new 7 clones certified from this variety for Touriga Franca. It's not easy to get clones for this variety because the team already know that there are not a variety with a huge variability inside the population. So that means it's more difficult to get, but they found at least 7 clones. So we know which is the clones, and we start to study these 7 clones in field. For example, for Touriga Franca, that normally is a variety that have a low sugar accumulation in field and sometimes have some problems with related sugar accumulation and ripening correctly at the end of the season, we found there are some statistical difference between the clones. For example, with a variation in bricks or in alcohol content from 1.5 degrees between the clones. So it's very important to choose the variety. Also, with the work promoted by the team related to the heat balance for Tempranillo, for Titerroris or Aragonés, as the variety is named in Portugal, with the synonym of Titerroris in Douro and Tempranillo, as you know. For example, they studied the 12 more sensitive clones for heat adaptation through the temperature of the leaf, compared with the 12 less sensitive for this. And this less sensitive for this shows, or better, the less sensitive for temperature shows a huge difference in temperature from the different clones that promote, even for a variety that is very sensitive for heat accumulation, a tool to choose which is the best clone to plant there, or to choose the clones to use a different elevation in our properties. Okay. Another one.
So there seems to be a lot of research about, from what I've seen, from the soil up, yeah, in terms of leaves, fruit, etc. Is there any research about the roots themselves? Like when you're irrigating, are the roots growing downwards or a bit more lateral? And like, do you see any difference in the vineyard when the roots are growing downwards or lateral?
So yeah, there are a lack of information on these of these issues. For example, related to how the roots develop, related to deficit irrigation. For example, let me make some information. There are some very few works done in Douro region in the past that was related to how the root system develops in terraces, in vertical vineyards, but was a study promoted in years 80, more or less, I think. And nowadays there are no more information about this. We are prepared, because I say to my colleague, because maybe I get more 6-7 years to get retired. And since we apply in some experimental vineyards from several years this strategy, we are ready to go deep in soil and apply the precise protocol to examine what happens to this root system. But, for example, we don't speak about this, but most of our experiments, trials nowadays is not about water application in vine, is how to apply the water. So how to apply in different frequencies, different amounts in order to promote a deeper growth of the roots in soil, in order to reduce the frequency needs of irrigation. Normally we can apply once per week, but if we, instead of 7 days, we can get a new irrigation for 9 or 10 days, this is huge efficiency for irrigation systems, for power, for energy, for sustainability, and even for resilience and adaptation of the vines, because we don't look at this only for the efficiency of the system, but most important for the efficiency of the vine. And another one candidate, one more maximum, or I get information from the... Yes, very quickly, very quickly, very quickly.
Can you explain to me, when you talk about sunscreens to the vines, what type of sunscreens, like what is the application?
The application are exogenous compounds with kaolin and other substances. It's like put a film, we spray with these compounds, the leaves, and it's like a film in the leaves and the bunches that protect from the radiation, and helps the vine regulate the temperature, the leaves temperature, the canopy temperature, and so on.
And is that organic?
Yeah, totally organic.
Yeah.
So, and the main impact, the main objective is to reduce the temperature of the leaf. And there are some works published already, even by the team that works now in this new project with us, that shows the impact of the reduction of temperature in the leaves and how this technique can promote more efficiency in the metabolism of the vine.
Yes,
Okay.
we have a trial with these new compounds near the restaurant where we will have lunch right now. So we finish the session and we will be back at 3 p.m. Thank you.